Hi, I'm David Ng. I'm a principal engineer in the Power Systems Group and Analog Devices. Many manufacturing processes involve potentially dangerous materials, such as flammable gases or combustible dust. When electronics are used in these environments, they must meet strict safety requirements that limit the amount of energy that can be released in the event of a fault, like a short circuit. Historically, wired communication requirements have been met by very reliable but very slow analog 4 to 20 milliamp loops and HART modems, which only reach data rates of a few hundred baud. Enter ADI's new Ethernet Advanced Physical Layer, or APL standard, which is an extension of single-pair Ethernet 10BASE-T1L technology for process automation and hazardous locations, enabling a data rate upgrade of thousands of times faster than what is typically available today. Today we introduce the hockey puck, which is a complete temperature sensing field device reference design that complies with the new APL standard and will be pre-certified to the stringent XIA intrinsic safety standards of IEC 60079. The hockey puck combines ADI's high-performance Ethernet PHY, low-power microcontroller, security, isolation, and data conversion ICs to handle communications and edge sensing for process field devices. ADI's LT8440, a new release power conditioning IC specifically designed for Ethernet APL, actively controls the input power to safe levels with minimal board space, greatly simplifying compliance to the APL standard. So here's the hockey puck, connected to an industry-standard 3-wire PT100 temperature sensor. The hockey puck reads the temperature and communicates through 2-wire Ethernet to an interface card that converts the 2-wire to standard 8-wire Cat5 and then connects to the PC. The PC then graphically displays the temperature. If you would like to know more about ADI's APL products and solution offerings, please visit analog.com and search for APL.